Hello, my name is Emerson Cortesar,
And I'm Sophia Glazareth.
and this is the Pulse Oximeter 1 group presentation for our final design. In our final design, we were tasked with creating an educational model to help the Duke Ignite Learners Health Program, where they attempt to teach about biomedical concepts to middle schoolers. Specifically, they need help with creating an interactive model to teach about pulse oximetry. Currently, they use a PowerPoint presentation, and they want a more engaging approach.
We created this two-part model. On the right here, we have a teaching about light absorption. We have a red cell up top and a green cell on the bottom, and the lights turn on. Students are then able to look at the white place at the bottom to see how the red light allows the red cell allows the red light to pass through, and the green light is absorbed. Therefore, on the bottom plate, you cannot see the green light. And the opposite is shown on this cell on the bottom. And this mimics how a pulse ox red blood cells allow the absorption of infrared light over red light.
Mm-hmm. And it teaches the difference between deoxygenated blood and oxygenated blood, between an infrared light and a red light. For this side, it teaches about how a pulse oximeter is used and the context of which is used in treating different illnesses, where a respiratory condition often leads to a lower blood oxygen level. For example, when you insert a healthy finger, it leads, you can't see it on the screen because it's reversed, but it is above a 90% reading in blood oxygen. And each of these correspond to a different illness. For example, COVID would have a lower one, and critical condition will have, of course, the lowest one. And for this, we used a couple of different approaches and materials. For the outer shell, it is a 13.5 by 20 inch by 8.47 inch box. We wanted to create a lightweight product so that Dr. Madonna, who is our client, could easily move it around. That's why it also has handles on the side to move it around. And because we had a durability design criteria, we ended up reinforcing this design with L brackets on each side, as you can see.
For the actual inside, we have a color sensor in order to sense which type of finger is inserted, as well as a 2-segment display to display the number in the end.
Or it's actually a 7-segment display, but 7-segment displays.
Oh, yes.
And then for this, it just simply recognizes each color. And then once it recognizes a range of colors, it outputs a random value to the screen to accurately show what the range of blood oxygen levels would be for that certain condition. And then on this side, we use epoxy cells that are painted a certain color in order to absorb light that is on the opposite side of the color spectrum and let light through on the same color spectrum.
Then we had LEDs to allow the light to pass through, and we used Arduinos to code everything, and 9-volt batteries to power everything.
Mm-hmm.
That's it.
That's literally a project.
Our design is divided into 2 educational models. The first one here to the left utilizes LEDs in complementary colors to demonstrate how lights are used to read blood oxygen. The red and green cells represent oxygenated and deoxygenated blood respectively. The red cell absorbs the red light and allows the green light to pass through, while the opposite is true of the green cell. On the right, we used a color sensor and fingers of various colors to mimic the readings you would get from a pulse oximeter based on different respiratory conditions. From left to right, we chose to represent healthy, COVID, emphysema, and critical condition readings. Our sensor is attached to an Arduino board, which randomly selects a number in the desired range associated to the finger's color. Our screen is made up of 2 single-digit screens and connects to the same Arduino. We 3D printed the model pulse oximeter and fingers, attaching the fingers to the box with retractable lanyards and O-rings. Our box is made up of 1/4-inch thick plywood and an acrylic screen. The box has 2 cutouts lined with grip tape to facilitate carrying. The bottom of the box is magnetically attached in order to upkeep the batteries and Arduinos.